All right, welcome to Algebra 2, Chapter 8, Section 1, Part B. And this, I'm not sure yet if we'll have one video or two. So first of all, this is about measures of spread. So the first part of Lesson 8.1 was on measures of central tendency, like mean, median, and mode. But now we're going to talk about how spread out the data is. One of those you're already familiar with. It's the interquartile range. The IQR is when you take the first quartile and you subtract it from the third quartile, and that range, that inner range, is one way of knowing how spread out your data is. Another measure of spread is standard deviation. And this is a huge tool in statistics that you need to understand where it comes from. So we're going to talk about that today. If mean is the average value, then standard deviation is the average distance from the mean. So you kind of find the middle by finding the average, and then you figure out how spread out your numbers are from that center. It's going to tell us kind of how consistent the values are. So when we look at different data sets, we'll be able to tell if they're really spread out or not. And to do that, we can just look at this one value called the standard deviation. How to calculate standard deviation? Well, in the process of calculating standard deviation, you actually find another somewhat useful tool called variance. So here are the steps. First of all, you find the mean. If you haven't seen it before, X with a bar over the top is the symbol for mean. So we know how to do that. We just find the average. Then you find the difference between the mean and each and every data value. You square those. And then to find the variance, the first thing, which is S sub X squared, you add all those squares that you just found in part 2 together and divide by the number of values. So it's kind of the average of the squares. And then the last step to find the standard deviation is you square root it. So it sounds like a lot of steps. It is a lot of numbers. We're going to do a few of these out, and then I'm going to show you how to use your calculator. So you're going to want to have your calculator handy. All right, first of all, we have our set of data here. This is the number of milligrams of a substance in a patient's blood found on consecutive doctor visits. Find the mean and standard deviation of the data. So first of all, to find the mean, you add all these up. And the sum of all of these numbers, add, you can use your calculator if you want to, is 100. And there are 10 numbers here, so the mean is 10. So X bar is 10. That's mean. Now we are going to do the process of what they said here. So we take the first data point, which is 14, and we're going to subtract X bar from it, which is 4. So I'm just going to go through and put all of the data points here. And it doesn't matter what order. If you want to put them in order, you can, but they're in this order, so I just kept them. All of these are going to be minus 10. So 13 minus 10, 16 minus 10, 9 minus 10 is a negative. When you get a negative, you need to write the negative here. 3 minus 10, 7 minus 10, 11 minus 10, 12, 11, and 4 minus 10 is negative 6. So those are our X minus the mean. That's our value of the sequence minus the mean. And then this next row down, we're just going to square each of those answers that we had. So 4 squared is 16. 3 squared is 9. 6 squared is 36. Negative 1 squared is 1. Negative 7 squared is 49. So you'll notice all of these numbers will be positive because we're squaring something. And so that kind of helps balance out the positive and negative, the ones that are above and below the mean. So the mean's kind of the middle, but some are above and some are below. All right, so that is subtracting them, squaring them. Now, in order to find the variance, you add up all of these, add them all up. And in this case, that adds up to 162 because I did it earlier. There are still 10 terms, so I divide by 10. So the variance, which is S, is 16.2. So that's my variance. And then the standard deviation is the square root of that, which is 4.02. We'll just round to the hundredths there. And that standard deviation. By the way, another symbol for standard deviation is this little Greek symbol here. And it's lowercase sigma. So sigma, if you've done any summation stuff before, is this. This is lowercase sigma. So it's still called sigma. All right, so that's the first example. Now let's run through another one that has a little bit different numbers and just make sure you've got this down. So if you want to give it a try, you're welcome to pause the video. I'm still going to walk us through it, and then I'm going to show you how you can use your calculator to help you out. All right, new data set here. We've got some smaller numbers. Notice these numbers only go from 0 to 5, and the first set, just to kind of get you familiar with what the standard deviation means. This set went from 3 to 14 if I was looking at range, so it's a little bit more spread out. So I am anticipating that on this next problem, my standard deviation will be less than 4 because it was 4 on the last problem. They were kind of spread out. This time I think it'll be smaller. All right, mean, add all those up. And there are 10 numbers again, so divide by 10, and that equals 1.4. So there's my mean. Take all of my terms in whatever order you want to, and subtract 1.4. So if I subtract 1.4, use your calculator if you need to, minus 1.4. Okay, and then you're definitely going to probably need your calculator for this one. We're going to take each of those numbers and square them. Keep them to like 2 decimal places. We're losing a little bit of accuracy maybe. If you have more complicated numbers, you might want to keep them in your calculator a little more accurately. I think we're actually keeping all our decimals right now, but you can see that this could get kind of crazy. And if we had a bigger data set, be really crazy. Okay, so I have found all of my x minus x bar squared, which is the mean, x minus the mean squared. Now we're going to add all of these up. Add, which is 26.4 divided by 10, which is 2.64, and that's my variance. And then I square root that number to get my standard deviation. This time it comes out to 1.6248. All right, so notice the standard deviation on this one is a lot smaller. So that means that this data is closer together. And you can tell by just kind of looking at those numbers that they're all pretty close to each other. The 5's sticking out there a little bit. All right, well, let's also use our calculator just to kind of check these. So let me show you how to use your calculator. First of all, if you have a TI, you're going to click Stat. And we need to put our numbers in. So put the X values into L1. So you go all the way in there, put that in L1, and pause the video, put them in. Okay, second step. In L2, when you're up at the top, you can put down at the equals, you can put 1.4 minus L1, and it will take 1.4. Oh, I did that backwards, right? Sorry. L1 minus 1.4. Let me fix my writing. Okay. So up here in our steps, what we're doing, the first thing is our X. So that's what we have. L1 minus, and we already found 1.4. I guess since you have these in there, you can add them all up and divide by 10. Yeah, I guess you just do that on your own. Okay, in L2, you're going to put L1 minus, and you can make your calculator say L1 by hitting second one. And then in L3, let's put L2 squared, right? Because we want to square it for this. And then we can take all of those and we can add those up. And there is a way to do the mean on your calculator, which I'm going to show you next. But so you can add all those values to find variance. And then you could square root it to find the standard deviation. Anyway, there is another way as well. So once you have them in L1, you can press, let's go different color here, press stat again, and go to the right to where it says calc across the top of the screen. And then you just want number 1, which is one variable statistics, one variable stats, and press enter, and you will get a whole bunch of things on your screen. An X bar is the mean, right? We already knew that. And I told you that this little symbol means sigma is the standard deviation. Okay, so we basically got the mean and the standard deviation from that data. Now you'll notice that 2.64 is not in that list, so the variance is not one of the items listed. How could you find variance if you knew this number, standard deviation? You could just square it to find the variance. So that's another way. All right, so let's try this next one on the calculator just to help it go a little bit faster. So just one more time here, this is what you will see kind of on your screen when you do a problem on the calculator. Most importantly, you got to be able to put those data values in stat edit, and then stat calc one variable statistics is going to give you this whole data. It even tells you how many terms there are. So in this data set, there were 11 terms. I know the mean was 10.5 and the standard deviation was 14. So this data is really spread out, whatever this data is. All right. So you can always check our arithmetic on these other values, make sure we did it right on these first couple problems by just plugging them in. All right, the next thing we're going to talk about here is outliers. So you may have talked about outliers when you first learned about statistics a little bit, and then that's a number that's just like doesn't really fit in the data. So if we're all measuring something like a phone and we measure in inches and we say, okay, my phone is 5 inches tall, and somebody comes up with the answer of 50, right? Maybe they used centimeters and got it wrong, but that's definitely going to be an outlier and maybe an error in our measurements. So we might not want to count that when we do average, because if we average all of our answers that were really close to 5 and then we throw in a 50 in there, it's going to throw our average way up. So there are 2 different ways to mathematically determine if you have an outlier. If you have a whole bunch of numbers like close to 5 and then you have 50, you're going to be able to look at your data and tell. But there is a mathematical rule for when it is actually an outlier or not, because sometimes it's just kind of close on the edge, but not all the way out. Anyway, method number 1, any value further than 3 standard deviations from the mean. So first you find the mean and standard deviation, which your calculator can spit right out for you. Then you take your standard deviation and multiply it by 3, and you'll add 3 standard deviations, and you'll subtract 3 standard deviations, and anything that's outside of that is an outlier. So if it's within 3 standard deviations, we're good. But if it's over here, then we're not. So you just add 3 standard deviations and subtract 3 standard deviations. Not super hard. And what else? The other method is if you have your interquartile method. So in order to do that, you need to have your first quartile and your third quartile, subtract them to get your interquartile. And then you also need to have the median, because that's the middle, right? The median is in the middle. You multiply this interquartile range by 1.5, and then you take your median and you add 1.5 times your IQR and you subtract 1.5 times your IQR. And whatever's inside of these two numbers is fine. Anything outside there will be an outlier. All right, so let's go ahead and try that out. Also, just to note, if an outlier is bigger than the mean, it makes the mean larger. So my example of measuring a phone and getting lots of things close to 5 and then throwing in a 50, that 50 is going to make my mean be something like 10, depending on how many people measured. It's going to way increase my mean. If the outlier is a small number, it's going to make the average or the mean smaller. And then also, no matter what, it doesn't matter if it's a small number or a big number, it's going to make the standard deviation bigger. Because remember, we're squaring numbers, so there is no negatives really with standard deviation, but it means my data is more spread out because there's an outlier out there. All right, so let's do one with real numbers here. So we've got the number of electoral votes in 2004 for 11 Western states shown on the map. Find the mean and standard deviation for the data. Identify any outliers using standard deviation method. So they're telling you which way to do it, and describe how they affect the mean and standard deviation. So let's start. First thing we're going to do is in our calculator in L1, so stat edit, put the numbers in. It does not matter what order you do. So if you do a different order than I do up here, I'm just writing down, but put these in your calculator. Make sure you don't miss any states. I think I got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I got 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I got 11. So I think we're good there. All right. So then what you want to do with that is stat calculate the one variable stats. And let's see what we got. So what does our mean look like? That would be the X bar. So that's the first thing on there. That's the 10.545. I'm just going to write it out that far. It goes further on your screen. And this is the slide you saw earlier with a little picture of the calculator had these numbers on here. The next numbers we're actually just not going to use. And then we're going to look at standard deviation, which is 14.3106. Just go a little while. All right, so we have our mean, we have our standard deviation. Now, what does it say to do next? Find the mean and standard deviation. Identify outliers. To find if you have an outlier, you do 3 times the standard deviation. So I'm just going to type in my calculator, 0.3106 times 3 is 42.9318. And then we need to take our mean, and we're going to add 42.9318, and we're going to subtract 42.9318. So what do we get? Mean was 10 minus and 1 with a plus. Okay, so if we subtract it, we get negative 32.38. And if we add it, we get 53.47. Okay. I'm just making sure I have this. All right, and then we just see, do we have anything outside of these? And notice that 55 is just barely outside. So I would have said like, of course 55 is an outlier. Look at it compared to those numbers. But it's actually really close. So 55 is an outlier. Excuse my writing. There we go. Describe how they affect the mean and standard deviation. So what would happen, or what did it do to my mean? My mean is made the mean bigger. And what did it do the standard deviation? It made the standard deviation bigger also. If there is an outlier, it will always make the standard deviation bigger. the mean, it made bigger because it's a big number. If it's a small number, this one could be smaller. All right. There is one more example here. So you're welcome to pause the video, put those in L1, and then we'll get started. So pause the video and come on back. All right, so we put that in our calculator and we got the mean is 5.36 and the standard deviation is 4.3195, and it keeps going, but I'm going to go that far. We're going to do both methods this time, so I'm just doing the standard deviation first. We're going to do 3 times the standard deviation and add and subtract it to the mean. So actually, I should put the mean over here. Take the mean plus and minus 3 standard deviations. And what does that give us? If we subtract that, we get 12 point, nope, that's the 3 times. 3 times it is 12 point whatever. We get negative 7.6. And if we add it, we get 18.32. Are there any numbers in this list outside of that? 19 is an outlier. I apparently want to put my L before my T in outlier. So it looks like this number 19 up here is outside of that range. So 19 is an outlier. 19 is bigger than my set of data, so 19 will make the mean will be larger and the standard deviation will be larger. You can use the sigma symbol or you can use abbreviations. For me, I am fine with that. All right, let's look at method number 2 for the IQR method. First of all, for the IQR method, you have to know your median and your quartile 1 and your quartile 3 and your median. So all of those are important. Really mostly just, yeah, you need your median. So quartile 1 is, let's put them in order. 2, 2, 2, 3, 3, 1, 2, 3, 4 fours, 1, 2, 3, 4, 3 sixes, 1, 2, 3, and a 19. Oh, a 10, 10, and then 19. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 terms. So 1, 2, 3, 4, 5, 6, 7. My median is 4. Take those 7 and cut them in half, and the middle would be a 3. Take these and cut them in half, and the median would be, or quartile 3 is a 6. All right, so for the IQR is 6 minus 3, which is 3. So my interquartile is 3. You do 1.5 times the IQR. 1.5 times 3 is 4.5. And then you take the first quartile. You actually don't need the median. Take the first quartile and you subtract 4.5. And you take the third quartile and you add 4.5. And this is your range of data. So do I have any outliers outside of this? Again, 19 is an outlier. And I don't need to write those answers again because that's the same. But it still makes 19 an outlier. Notice my spread of data is definitely different. So these two methods will have different results, whether numbers are outliers or not. So it depends which version you're using. And that finishes up lesson 8.1. Have a great day.